In this fifth example, I need to include the calculation of atoms because sometimes we calculate always molecules and you forget that the same relationship can be used for atoms. So in this case it says how many atoms of iron are present or in 100 grams of the element. So the first thing that we are going to do always is the same relationship, but in this case for atoms. 1 mole of iron atoms is equals to 56 grams of iron, and it's going to have 6.02 times 10 to the 23rd atoms of iron. Now in this case we are calculating atoms, so remember that the relationship is exactly the same. The only thing is that when we talk about molecules or formula units for the ionic compounds, we are going to add up all the elements that are present. In this case the element is only one, that's why we use the atoms instead. So how many atoms? Here we have atoms, so how many atoms is my X? And then are there in 100 grams? So 100 grams is the mass. I put 100 grams of iron underneath the mass. I'm not going to use the mole information. So in this case my X is going to be as simple as multiplying the Avogadro's number, which is this number. I don't know if I named that before, but this is also called Avogadro's number. So X will be 100 grams of iron times 6.02 times 10 to the 23rd atoms of iron over 56 grams of iron, which can be cancelled with these grams of iron. So X is going to be 100 over 56 times 6.02 times 10 to the 23rd atoms of iron. And doing my calculation again using my calculator, I have 100 times 6.02 exponential 23rd divided by 56. This X is 1.075 times 10 to the 24th atoms of iron. In the case that we have only atoms present, that is not a problem. But sometimes they are going to ask me to calculate the number of atoms present in 100 grams of a compound. So we are going to see how to do that in a few minutes. Okay, but for calculating the number of atoms present in a sample of a compound, we need to reason something. If we have one molecule of water, for example, we are going to have 2 atoms of hydrogen and 1 atom of oxygen. Yes? If we have 12 molecules of water, we are going to have 24 atoms of hydrogen, because each atom of hydrogen appears twice. So one molecule is 2 atoms. 2 molecules is going to be always double, so 12 molecules, which is 12, is going to have double the amount of atoms of hydrogen, and the same amount, because we have 1 atom for each molecule. If we have 12 molecules, we are going to have 12 atoms of oxygen. Okay? The same relationship goes with a mole. If we have 1 mole of water molecules, we are going to have 6.02 times 10 to the 23rd molecules. But if we can calculate the hydrogen and the oxygen, the amount of oxygens is going to be the same thing, because for each molecule we have only 1 oxygen. So the amount of oxygen is going to be 6.02 times 10 to the 23rd atoms of oxygen. But in the case of the hydrogen, we have 6.02 times 10 to the 23rd times 2. Why is times 2? Because the hydrogen appears twice. So this is going to be 6.02. Let's do it with a calculator so we don't make mistakes. Exponential 23 times 2. This is going to be 1.204 times 10 to the 24 atoms of hydrogen. So independently of the amount that we have, if we calculate the amount of molecules, we can get the ratio of each atom that we have, because knowing the amount of molecules that we have, we know that the hydrogen is going to be double because it appears twice, and the oxygen appears once, so it's going to be the same amount. So in the question that I have here as an example, and normally these kind of questions do not appear in tests and all that because the students have a lot of problems with that. It says how many atoms of hydrogen will be present in 180 grams of water. So what we can calculate first is the amount of, calculate the number of molecules. And then we know that the number of molecules then times 2 is going to be the number of atoms of hydrogen. So the same thing always, 1 mole of water is equals to 18 grams of water, and it's going to be 6.02 times 10 to the 23rd molecules of water. Or you can put also directly here the number of hydrogens, because in 18 grams of water, since it's 1 mole, it's going to be this twice. But let's do it in two steps. So first we calculate the number of molecules of water, and this is going to be here, and then we are going to multiply by 2. So it says how many atoms. I'm going to calculate first how many molecules are in 180 grams of water. So my x, again, I don't use this one. I'm going to multiply these two and divide by this, which is the same as multiplying 6.02 times 10 to the 23rd times 10, because this one is 10 times this one. Yes? So it's 6.02 times 10 to the 23rd times 10. So it's 6.02 times 10 to the 24, because it's 10 to the first. That is multiplying 10 to the 23rd. So it's going to be 10 to the 24th molecules of water. And once we have this one, we need to multiply this times 2, because the hydrogen appears, where is the hydrogen? Water, here. The hydrogen appears 2. So my x will be, or my y if you want, is 2 times 6.02 times 10 to the 24 atoms of hydrogen. Okay, so in this case it's going to be 1.204 times 10 to the 25th, I think, atoms of hydrogen. Let's verify that with the calculator. We have 6.02 exponential 24 times 2, 1.204 times 10 to the 25th atoms of hydrogen present in 180 grams of water. Okay, so if you have the number of atoms present in a formula, then you need to calculate. First calculate the number of molecules and then see how many atoms are present in the formula, and you are going to multiply by that number to get the amount of atoms. Of course, if it's the number of atoms of oxygen that they are asking you, you don't have to multiply. The number of molecules of water is going to be consistent with the amount of oxygens, because it appears only once in the formula. Okay?